Here I'll be showing you how to create a bootloader for the MicroBlaze processor and how to start the processor application from the QSPI flash which is present on your FPGA board. This is the hardware which I am using for this demonstration. That is the AC701 Evaluation board from Xilinx, which is having an Artix 7 FPGA in it, and it is also having a 256 MB QSPI flash. Uh, in that we will be storing the bitstream as well as the processor application, and then we'll boot the application from that QSPI flash. And I'm using Vivado and SDK version 2018 for this demonstration. These are the steps involved in the overall process. So there are around 10 steps in total. Each of the step individually are very simple steps, but if you don't know these steps, you might end up spending a lot of time in finding out the right procedure. So I hope this will help you to save some time. Now we'll go through each of this step and I'll explain each step in detail. First, you need to complete your RTL and processor application development and test the complete functionality by downloading it into the board through the JTAG interface. And once that functionality testing is completed, then you can start the first step for putting your application onto the non-volatile memory. So I am assuming that you already have a working RTL and the corresponding software application ready. Here for this demonstration, I'll be using an application which I already made and ready, which involves a MicroBlaze processor and an Ethernet MAC, which you can use for communicating with your host system. I will not be showing the creation of that project here. If you want to know how to create that project from the scratch, you can see the link given in the description. So the first step what we have to do is to open your RTL design in Vivado and then add AXI quad SPI IP to your RTL design. So let's go ahead and do that first. So now I have opened the design which is having both MicroBlaze and Ethernet in it. So now we'll go ahead and add the AXI quad SPI IP into this design. Just search for the AXI quad SPI. This is the IP which you need to add. You can do the connection automation to route the SPI lines and the AXI lines. So the connection automation is done. If you need to configure this IP, so just double click on this IP and this SPI interface should be selected as SPI flash, and in the IP configuration tab you have to verify that the mode is selected as standard, and all the settings can be left as such. You need not change anything. And if you take a closer look at the IP, you can see that you need to connect an external SPI clock and the interrupt line needs to be routed manually. So for this IP we will create a separate 50 megahertz clock. So you can go to the clocking wizard. So this is a clocking wizard which I am having in my design. So I'll create a new 50 megahertz clock, and that can be connected to the AXI SPI module. So just go to the output clocks tab, create a new clock and change the value to 50 megahertz. Then click OK. Now you can connect the external SPI clock to this newly created 50 megahertz output. So that is connected now, and you also need to connect the interrupt line. So for that, this interrupt concatenation unit needs to be modified to take one more input. Right now it's having 5 inputs, so you need to reconfigure it to take 6 inputs. So just change this 5 to 6. So now one additional input has been created. To this you can connect the interrupt line of the AXI SPI module. So now this line is connected to the newly created input of the interrupt concatenation unit, and this is the 50 MHz clock which has been created in the clocking wizard. So now we have added the AXI quad SPI module and connected all the required lines. Now we can go to the next step. Before that, just save your design, save the block design. So the next step was to create a constraint file for the bitstream. So we'll go ahead and do that now. It's better to create a separate constraint file for storing the bitstream configuration. So for that, go to the sources tab and click on the constraints option and click the plus button. Add or create constraints, click next, create file and give some file name and click OK. Click finish. So you can see that a new file, XDC file has been created. So right click on this file and set this as the target constraint file, and then again right click on this, and we'll use this XDC file only during the implementation. So set that option using this set used in, and then uncheck this synthesis option. We will not be using in synthesis, we will be using only in the implementation phase, and click OK. So the next step is to open the synthesized design and edit the device properties. So we'll go ahead and do that. So just click on the open synthesized design. Once the synthesized design is opened, you can go to the tools menu and click on the edit device properties. So here you can change the bitstream configurations. So you can go to the second tab, which is the configuration tab, and you can change the configuration rate if you want to increase the boot up speed. So I'm putting 6 megahertz. And then you can go to the configuration SPI configuration. Since we are targeting SPI flash, you have to go to the SPI configuration and change the bus width. By default it will be shown as none, so we will be using quad SPI, so we'll choose this 4. Other options you can leave as such, and then you can go to the configuration modes tab. Here again we'll select the master SPI into 4 option. So that's it. Other options you can leave it as such and just click OK, and then you have to save this changes, so that changes will be reflected into the bitstream XDC file which you created. Now you can close the synthesized design. You can open and see the XD constraint file which you created. You can see all the changes whatever you have made in the configuration menu has already been reflected in this file. So the next step was to generate the bitstream and export this hardware to the SDK. So let's do that now. So now you can go ahead and click the generate bitstream option. Now the bitstream generation is completed. Now we need to export this design to the SDK. So go to the export and then export hardware. Check this include bitstream option and click OK. Now the design is exported to the SDK. Now we can launch SDK for developing the bootloader application. So launch SDK. So the next step was to generate the SPI bootloader and configure it. For this, go to the file menu, click on the new application project. You can give any name for your bootloader. The OS should be selected as standalone, and make sure that you are selecting the newly exported hardware file, and other options you can leave it as such, and click next and select the last option in the templates, which is the SREC SPI bootloader, and click finish. Now you need to modify the BSP settings to select the correct option for the SPI flash. For that, go to this modify BSP settings option and select this XIL standalone library. Here you can see two options, serial flash family and the flash interface. The family by default value is given as 1. In the AC701 board what I am using for this demonstration, it is having QSPI flash from Micron. So as you can see here, the value should be 5 for Micron flash. So I'll change this value to 5. And the SPI serial flash interface value 1 is to be given for AXI SPI, so we'll leave it as such and click OK. It will automatically regenerate the BSP sources and compile the application again. Wait for it to complete. Now one more thing you need to do is to give the offset address inside your flash where you are storing your application. So for that you have to go to the bootloader application folder, go to the source directory, then open the blconfig.h file. Now here you can see a parameter called flash image base address. It is very important to note that even though the name is given as base address, it is actually the offset address what it is expecting. So you need to give the base address wherever you are storing the your application. So for this particular demo, I am planning to divide the flash exactly into two portions. In the first portion, I'll be storing the bitstream for configuring the FPG, and in the second portion, I'll be storing the application for the MicroBlaze processor. So the offset address should be changed to half of the uh, 32 MB flash address space. So this corresponds to 16 MB address. So this is the location where I'm going to store the processor application. Now save the file, and you can also change one more thing, that you can open this bootloader.c and disable this verbose definition, otherwise your bootloader is loading process is going to take a lot of time. So you can just disable this and save the file. So it has completed the compilation. Now the bootloader executable file, that is the ELF file, MicroBlaze bootloader.elf is ready. Now next step is we need to combine this bootloader with the bitstream which we have already generated. So the next step is to combine the bootloader ELF to the bitstream and generate a new bitstream. So that we need to do in the Vivado IDE. Now for combining the bitstream and the bootloader ELF, go to this tools menu, go to this associate ELF files option, and uh, select this MicroBlaze processor under the uh, design sources, and click on this button and click add files and browse to the folder where your ELF file is located. So this is the ELF file, bootloader ELF file, which was generated just now. So just click OK, and then again you can click OK. So here you can see that the bootloader.elf is selected now, and you can just click OK again. Now you can see that the bitstream is out of date, so you need to regenerate the bitstream to combine these old bitstream and the bootloader ELF and generate a new bitstream file. So click on the generate bitstream option, and wait for it to complete the bitstream generation process. Now the bitstream generation is completed. Now the next step is to convert this new bitstream file into a file which can be stored on the flash. So we'll be converting it into bin file. For this, again go to tools menu, click on the generate memory configuration file, select the file format as bin, and you need to select the memory part as well. From the datasheet of the evaluation board what we are using, that is AC701, you can find out the memory part. It is from Micron, it is 256 MB flash, and this is the part number which is being used, the 3.3 volt version. This is what is there in the AC701 board. So select the uh, flash part number, and you need to give a file name for the bin file which is going to be generated. Then you need to select the interface type. We have to select the quad SPI X4 option, and we also need to provide the bitstream. So check this load bitstream option, and you need to browse and select the bits file which is to be used for this. So just browse through the folders and find out the bit file which was generated. This is the one which was generated just now. So select the bit file, and other options you can leave it as such and just click OK. Now the bin file for your corresponding to your bitstream has been generated. Next step is to write this file into your flash memory in your evaluation board. So now you can switch on your evaluation board and then launch the hardware manager. You open target and auto connect. Your board will be detected and your device will be shown. Here you can see the FPGA device which is present in your uh, evaluation board. Just right click on that and click on this add configuration memory device option, and here you have to select the memory part number again. So it's a Micron. The part number has been selected, and now the QSPI flash has been added to it. Now you can program this by right clicking and selecting this program configuration memory device option. So here you need to give the configuration file, which was the bin file which we just generated. So browse and select the bin file. This was a bin file which we generated just now. So select that bin file. Other options can be left as such. And just click OK. So it will erase the flash and write this new bin file onto the flash memory device. This is going to take some time. Now the bin file has been successfully written into the flash. Next step is to write the processor application software ELF into the flash in SREC format. For that we will use SDK. You can go to the Xilinx menu and then select this program flash. Now we are about to write the ELF file which contains the actual application program for the processor. In this demo I will be using the default LWAP test program which was already available here. Select the image file, that is the ELF file which you want to load into the flash. This is the test software ELF file. So select that file and you have to give the correct offset which we have already given in the blconfig.h file. So that was 0x01. This was the offset address we are given, and you also need to select the flash type. Just select the correct device from the list. Ours is MT25 QL256. So this is the device, and you should not forget to check this convert ELF file into bootable SREC format, because we will be storing the program in the SREC format in the flash. The bootloader what we have created is also for the SREC format, and then you can click the program. Now the file has been successfully written into the flash. So that's it. The last step was to restart your board. Before switching on the board again, don't forget to close your hardware manager in Vivado, otherwise your hardware manager will try to connect to the FPGA and your booting will not happen. So close the hardware manager, then switch off your board and switch on again. To see the output of the program, I am using Teraterm. So select the correct serial port and start the Teraterm terminal, and now you can switch on your board. It will take some time for the bootloader to load the SREC file from the flash to the RAM and execute the program. So wait for the program to start. So now you can see that the program has been started, and this is the output of the LWAP demo program. So that completes the demonstration of the creation of bootloader for the MicroBlaze program and starting the processor application from the QSPI flash.